All right, well, let's see what you should have got here. Okay, so you found the area of the square to be 4, the top one there, and then the bigger one was 36, so a factor increase of 9. And yet our side length increase was only 3. Same thing with the circle. You would have got 36 pi compared to 4 pi. Okay, again, a factor of 9. Let's talk about units here. This might have something to do, if we're talking about centimeters here, okay, this would be, let's get rid of these circles here. This would be 3 centimeters. The area would be 36 centimeters squared. I wonder if that's important. Maybe that's why I'm saying it like that. 4 centimeters squared. Same thing for the area of the circle, right? It's going to be 36 pi centimeters squared. 4 pi centimeters squared. And so I increased this, the radius, by a factor of 3, and my increase in area was by a factor of 9. Can we make the connection yet? Okay, so obviously the difference, or the relationship then, is not a one-to-one relationship, but rather it's like a squared relationship. Okay, so for perimeter, you double the perimeter, double the side length, double the perimeter. For surface area, or sorry, for area, if you double it, you increase it by a factor of 4. And if you triple it, by a factor of 9. If you quadruple it, that's right, a factor of 16. Okay? And if you don't believe me, go ahead and figure it out. Okay? Just like that. An area of a square with side length of 1 is 1, side length of 4 is 16, so I multiplied it by 16 because 1 times 4 is 4. Okay? And so then 1 times 16, which is 4 squared, is 16. And it works for rectangles as well, and for triangles and any other shape. Just the squares and circles are easiest to do. Okay? So there you go. And the nice thing is that this is not limited to area of a two-dimensional shape, but the surface area of a three-dimensional one. Okay, so if you found the surface area of these two rectangular prisms, I'm not using cubes this time, or spheres, just to do something different, but these are similar figures because you'll notice these dimensions here are all half these dimensions there, the corresponding dimensions. Okay, so then the surface area of any object is expressed in units squared, just like area is. So then you would expect that because it's units squared, that the relationship would be a squared reference. Okay, so if you multiply the side lengths by 2, 2 squared is 4. That'll be a 4 times increase in surface area. If we go ahead and work it out, you get 122 centimeters squared, and then for the larger one, you get 488. So times 4. Okay. Now the reason why that is for all the ones that are areas, because you have two dimensions that you're multiplying both by 2 in this example, right? So in other words, I'm doing the surface area, or the area of this face here is 3 by 4. And there's two of them, so I go 2 times 3 times 4. But if to get the area of this face, I'm doubling both measurements. In other words, I'm doing 2 times, and then 2 times 3 is the height, which is 6, times 2 times 4, or yeah, 2 times 4, which is the length, okay? And so I'm basically going 2 times 2, which is 4, times my original area. So that's why it's a squared relationship like that. Okay, so what I want you to do is to look at this problem here. I'm not going to give you, I don't want you to calculate the surface area of the second one using traditional methods. I just want you to look at, these are similar figures, obviously, okay? Use the ratio of corresponding sides to figure out how much have increased the side lengths on the larger triangular prism. Use that and what you know about the relationship between two similar objects and their surface areas, and figure out what the surface area is of the larger object. Okay, and bring that to class on Tuesday. So you won't find out if you're right until Tuesday. We'll see you then. You better bring it to class. I might even check to see that it's done, like homework.